Okay, welcome back, everyone. This is going to be lesson 13H, where I'm sketching this highlighted graph here, which is y equals negative sec 2x minus pi on 2 plus 1. Now, I am given the domain of negative pi to pi. However, I'm going to change this to 0 to 2 pi. That way, my graph is going to begin and end kind of halfway through my wavelengths, just to make things a little bit more interesting for our sketch and to also give you guys an example that's going to be slightly more challenging, but also more helpful for answering other questions. So there are two steps doing any reciprocal trig function sketching. So step one is to sketch original trig function. So if it's sec in this case, I'm going to sketch cos, and then step two is to sketch the reciprocal. Step two does kind of feel like that is just do the entire question. However, it's actually pretty straightforward to sketch a reciprocal if I already know what the original function looks like. If my graph is of y equals negative sec 2x minus pi on 2 plus 1, then my original function is going to be y equals negative cos. Again, always using my third letter. My third letter is C, so it's going to be a cos function. 2x minus pi on 2 plus 1. Now, hopefully you've all watched the video and we feel pretty comfortable doing this sketch. So I'm going to do this in a little bit of a quicker way and kind of help show you guys an example of how you can do these trig sketches a little bit more fluently. So my first step is to consider that my coefficient of x is not 1. So I need to take 2 as a common factor out of my function. That's going to give negative 2 cos brackets 2 x minus pi on 4 now plus 1. And again, this here has changed, just note, because I've taken 2 out as a common factor. So if I describe the transformations, which this question does ask for, I'm just going to do it for a cos function. It's the exact same for our reciprocal. I have been reflected in the x-axis. Dilation factor in this case is 2 because it's 1 over. It's going to be a half, which basically means that my period t is equal to 2 pi over 2, which equals just pi. It's going to start from positive pi on 4. It's going to be shifted plus 1 in y direction, and I've written it's going to start at plus pi on 4, but that means it is shifted to the right, positive pi on 4, just to use like the technical terms. But how we can think of it, if we're not asked to do the descriptions, these are all fine ways to write things. The official way would be like this. You could just write the period like this. Again, let's try and get a picture in our mind of what our key information is. You can just scribble it out like so. So now if I do my graph of cos with this information in mind, so it's shifted up by 1, which means I'm going to have a equilibrium line like so. And it's going to go plus or minus 1 from 1. So it's going to be here at 0 or up here at 2. I have seen people draw kind of broken lines for the top part as well, just to help kind of give them some guidelines to make their sketches neater. If you want to do that, you are more than welcome to go about it that way. So once I know this, I know my graph is a cosine graph. So we start at a peak. So normally my cosine graph would start at some peak up here. However, it is a negative, so it's going to be reflected, which means it's going to start all the way down here at pi on 4. Now, if I look at my key intervals, that's one thing I haven't put down. So my critical point intervals is going to be pi on 4. So the period divided by 4 in this case. So if I start here and I draw my waves, if I keep adding pi on 4, just give me a better idea of kind of where my wave ends. Then I'm going to have, it's going to cut the equilibrium at pi on 2 or 2 pi on 4. Then it's going to be 3 pi on 4 is going to be a peak. Pi is going to be back to the equilibrium. I need a little bit more space here. So I'm going up to 2 pi this time. So then it's going to be 5 pi on 4, 5 pi on 4. And then here I'm going to have 2 pi. So because it's sine, I'm starting from, let's just do blue. Starting from here, equilibrium, peak, equilibrium, trough, equilibrium, peak, back to equilibrium. So you're going to have a graph that looks something like that. Just another way to sketch. If I go back by pi on 4, then you guys will be able to see that I actually meet all the way back up here to my equilibrium as well. So that's just a way to do a quick sketch of my cos graph. I still actually went quite slow, but you can kind of get this idea. You can start sketching these graphs with pretty good fluency for even the more complex ones. So once I've established my original trig function graph, I now want to look at sketching the reciprocal. Now I know everywhere here where it cuts my equilibrium point, I'm going to have a 0 value for my cos graph. So that means I'm going to have asymptotes at these points. Again, I have a pretty good idea of what these shapes are. Let's do some, I need a different color. Let's do purple. Let's put some broken lines through here to represent my asymptotes. Because again, I'm not sketching a cosine graph. I'm having to sketch a reciprocal trig function. So once I've drawn my asymptotes, now I'm going to sketch my sec function. And it should look something like that. So my sec graph is the one in purple. I've got all these points everywhere. I can get rid of these points now because I've kind of figured out the key idea of what I'm trying to do. You're welcome to leave these on in the exam. I actually would recommend leaving them on, but just to make it a little bit clearer as to what I have happening. That is my graph of my reciprocal trig function. So as long as I can sketch my original trig function, I can make the reciprocal graph of any trig function.